Let's get started. Hi, good evening. Let's start. Not object-oriented programming. Why it's coming here? Okay. So last time we had a look at the try and catch and other overall MySQL, how to write, read queries and everything, right? Have you practiced on these things? And any challenges in understanding or executing these database queries or the exception catching scenarios in Python? Anybody have any problem?
I didn't really look into it, but I actually know how it works, so it should be okay.
But you tried it, right? You've done it before.
Before, yes, I've done it long before. I know what exactly it is, so it should be fine.
Okay. But the practicing is really, kind of required, because when you go as deep and step forward, there'll be a need to refer to these things. So I'll request you to go through it once, try a couple of programs, and I think I've given you the source code and everything as well, right? So you can just cut, copy, paste here and start using it. Okay.
Okay, sure.
Balaji, how are you, sir? Have you?
Sure. No, I'm having some challenges with my installation, Ravindra, but I'll know this weekend. I'm going to planning to sit down at Ravindra. Yeah.
Let me know if I can help you in any way.
Sure. No worries, Ravindra. Yeah.
Yes, sir. Let's get started. Let's take a step ahead and let's try to understand, files today. Let's try to understand the OOPS concept more or less from the interview perspective. I believe you know OOPS concept, but in Python data science community, they have some specific, definition given. And as we know, the OOPS definitions are quite tricky in, basically when it comes to a typical group of people and all, right? So we'll basically go through those things today. Okay, so let's try to understand file here. We understand database, right? But database is like kind of storing the data on some other computer, logically, physically, or mostly on the cloud. But as far as files goes, files are the great mechanism as when you look at the Python in terms of how you can get them accessed at locally. Could you explain me what's the difference between file and database? Just give me a minute, please. Just give me a minute. Yes. So can you tell me what's the difference between a database and file?
Yeah. Database is like, you can imagine it kind of like a server. Say like multiple people can connect to the database at a single point of time, whereas file is kind of like you kind of like lock it, or it depends on the type of file what you're using. Okay, it may not support like a multiple server kind of like concept. It's like just for logging and those things and all, but you can use kind of like a file.
And also, like, I think in database, data is defined and it's categorized, but in files, it usually comes like on a continuous text, or it's not as classified data.
Come again, I couldn't get your last sentence, ma'am.
Probably in files, the data is not as organized, but in database, it's all kept in an organized manner. So I think in files, it's hard to read everything from the files because it's like in a continuous flow.
Okay, let me take the other side of the coin. Okay, means I know why you trust and why you're more aligned with the database. But whenever we talk about something like data scientists, right? We want to build a solution which is much more efficient. The priority is making it efficient, and efficient in a way that we have to process a big chunk of data in a few minutes, few seconds if possible. Okay. Now, when you try to compare database with files have much more bigger importance in Python data science partigram as such, because what we are trying to do, we are trying to churn out big amount of data, which is stored, if not, as you say, categorically in the way we have database, we have tables, like we have records, we have categories and all those things. But if you look at the files, these are sequential data mechanism. And if you have something like text file, it can churn data. And as we know, we normally create our libraries as per the processors, the infrastructure, the hardware available to us, right? So whenever you want to understand the actual throughput of be any data like text or something to be churned out at a larger, size in a petabytes or so within a few seconds, then file is really great options, because what you're trying to do, you're trying to churn out the data locally, so it will be faster. You're not dependent on network. You have the infrastructure power, rather the processor, the RAM, and all those power at your disposal. Because if you're churning the data locally, these things do play a more important part rather than the database. Database is normally, if it's physically available, it's almost as similar as file. Like you say, you install a local database server, but then the database server which you install locally doesn't have that many facility in terms of encryption, in terms of security. So it's as good as files. So whenever there's a need of churning data, and if you have the infrastructure or the power available locally, we normally go with file. So if you compare with, like with other programming mechanisms, or other solution spaces, Python data science specifically stress more on files rather than the database. Why? I've just explained you. Does that make sense? Means what I'm speaking, does that make sense to you?
Yes, yes. It's more moldable, right? The file data in the file can be used anywhere and as needed, but database,
Right.
it's in its own format. Yeah.
Right. And if you use text files, means non-binary file, that can get compressed up to 99%. So like, if you want to, churn out a file, it will get access at much faster rate. And if you're doing it locally, I'm just wasting one additional cycles to get it decrypted, right? Or decompressed, to be precise. So this way, what I try to do, I try to achieve the maximum throughput of data, which is required locally, if possible. What I can do, I can just buffer the data on my local drive or local, infrastructure, or RAM if possible. If not, then at least local drive. And as we know, the current infrastructure, we have really big amount of mass storage, as in, those memory cards, right? We normally use the SSD drives, if you heard of. Have you heard of SSD drives?
Yes.
Solid state, yeah.
Yes, solid state drives. These are like RAM. Means previously used to call them, means these are the chip-based memory storage. Now we use them in petabytes, and we use this, storage locally available to you. Local in the sense to your desktop or the desktop next to you physically. We are not talking about something over the network in the sense something over the internet and all. Whenever you try to crunch out big amount of data, and if it's you can do it locally, it'll be with the maximum efficiency and maximum security, because physically you're not shifting the data from your network to another network. If it's a local network, even just the PC besides you, you can expect a gigabyte per second kind of speeds, right? And if you have really a couple of parallel network keyboard set up locally, then the speed can be really multiplied in a way. So that way, specifically in Python data science, when we churn out data, something like if you can really relate to a solution, let's try to understand these global maps, right? We have global maps which we discussed, like Python, we can create the global map with a tiling infrastructure, right? With a tiling pattern. So I have these Google Maps, locally available data with me, which is a basically mix and match of binary and text. Binary in the sense I just need to pinpoint or relate to a particular tile, but otherwise everything in terms of metadata available in the text. So it's almost, if you look at the solution-wise space, it's 80-20 kind of thing. So 20 binary, 80 text. So here what I do, I just get that data dump of a, whatever area I need to analyze. I'll dump it on my system if I have the space available, be it something like magnetic hard drive, the older way, or the newer way, the SSDs of the world, where I can really churn the data at the speed of 500 gig per second. Means you might have seen the specification of SSDs now available. with your laptop. Means if you go and purchase a laptop, let's say for Dell, HP, or all those popular brands, you can get SSDs. You don't have to have anything which is going rotating somewhere, or getting damaged at some point in time because the platform is vibrating and all those things. So like that, what I have a complete solid state laptop with me. Well, LCD have some pressure, liquid crystals and all those things, but otherwise the laptop is almost pardon me, the laptop is almost at a solid state, and that's why we normally go with files rather than database. And as we know, the text can get compressed up to 99%. We can have all these data churned at very high speed with this solid state drive or the infrastructure available as of now. So file does play a crucial part in data scientist solution giving. And I believe you could be able to explain this thing. I'll share the recording of this video also, so you can have it a go again. You can search on the Google why data scientists prefer file handling over database, and something like that sort. So you'll get the advantages and disadvantages also. Well, the disadvantages, if you can't really configure the physical security of your local system, or if it's still able to let the other person take the control in a way, like somebody like hacker might be ethical hacker or unethical hacker, whatnot. If you let him take the control, means if your infrastructure is still connected to the net, then the security might get damaged. But overall, if you're doing anything locally which is detached from the net or intranet, then your PC is quite secure in a scenario, and that's how we normally churn our data, right? So that way, the churning speed, we can go up to much better than a database in most of the scenario, and that's why we normally prefer file read writes over database in terms of Python. But if you look at other ways, they don't need that much throughput. Well, in banking, transactional system, or stock market, they might need, and they are also going to the they are also checking, how does Python read write, and other options available, and they might migrating to Python in near future. But that they look out as far as solution upgradation concerned. But as far as data scientist goes, this is one of the best blessing we have, and that's why Python read write is really crucial to us. Means the better we learn this, the better we could be able to churn out data at a faster rate whenever the solution demands. And believe me, as far as the data scientist solution goes, there is always a demand of churning huge amount of data, might be text or binary, and based on that, we need to suggest solution. As I told you earlier, I am more of a solution architect than a developer. So whatever you get from me as a guidance, it'll be much more useful whenever you start building solution as a data scientist. Think it from that angle rather than let me get this thing working and those scenarios. Yes, you need to try out, because unless you try out, you will not get the idea like how it works on a ground. Okay, I give you a code snippet just to get you started. I'm not giving you a complete source code of a solution or something like that sort. Well, if there's a need, I will give you. But overall, what I would really love to, you to try certain basic things on own, and then we can build our solution on top of that. Does that make sense, sir, madam? Will that help you?
Sure.
Yes,
Sure,
yes.
sure.
Yeah. And pardon me, my throat is not still up to mark, so you'll have this throat clearance more events in today's session. Pardon me for that. Okay,
Sure.
so let's try to understand this read write thing. So as every platform has a file handling, in Python we also have a file handling, and which is much more easier than C or Java, and for that matters. As we know, we don't typecast any variable whenever we define it, right? That way, your code is much easier whenever you start accessing file. Let's see how. Okay, and if you want to compare the typical other file handlings, like we have a key functions, for working with files, like we have to open the file, to load it, to get it connected, and so on and so forth. So open function takes two parameters normally, file name and a mode. So file name is basically normally targets to the last pointing directory. So whenever you try to open a file, it will try to find the file if you are not mentioned the path to the basic default directory. And Python uses Linux symbols to access directories. So that's a forward slash rather than the reverse slash, the way DOS uses or the Windows uses. Okay, so here open, read, R for read. So read is basically just reading it. You are just loading the data into memory. So if you have really great number of RAM available to you, and if you know the SSDs of the world, even if they are hard drive, but if you look at the actual processor to SSD configuration, they can act as a RAM in most of the scenario. So if you are loading the file into the SSD, it will perform as at the speed of the random access memory, because the churning cycles get reduced to basic minimum, and you have throughputs like 500 gigs per second. So that's why read access is the fastest in all file conversions. You are just reading the file, right? And so on and so forth. Then we have something called append. So what do you mean by append? Append opens the file, and whatever you want to add, it's get appended at the end. So there's a data, and the data gets added. It's like first in, last out scenario. Okay, philo, that's how we call it normally. So it's an appending mode. Then W, write. Write means you load a file, and then you'll select a pointer or a record name or a by where clause, and then start updating the line, record, index, whatever you want to update, right? In files, we normally don't have record and category. We normally just have a line number. And if your database is flat enough, I'm specifically mentioning here database because the file can act as a data storage, and that's how we use as a data scientist, we use this file read write for the maximum efficiency, for the maximum data churnouts. That's why file read write is more of a normal practice than the database read writes as far as Python data science processing is concerned. I'm not talking about the normal, solution access. Those are there, and for that we normally use database, because whenever you upload the data to the internet, it's much more secure if you go it through database, because database have added layer of encryption, access right, authorization, authentication. Even you can go to a level where you can use triple slice encryption for a database access as well, like we use in the financial transaction, credit card, debit card transaction. Okay, these are multi-level transaction, normally 3 or 4 level transactions, encryption, 4 level or 3 level encryptions we are talking about. So they are almost impossible for any hacker to penetrate. There are very few instances of penetrating this 4 layer or 3 layer encryption as far as the transactional mode goes. That's why nowadays, if you look, there are very few transactional systems got hacked. Okay, so we have made them really unpenetrable in a scenario. And this was happened in the last 1.5 years. Then we have text default value. By default, we open the file in a text mode, and if you have something like images, like you have written an image decoding program or something like that, then only we normally go with a binary mode. You can open a file in both the modes separately as well, and that's a kind of added thing we have in, well, we can do it in C and Java as well. So it's not specifically as far as Python goes, but yeah, we have these things available in other platform as well. Does that make sense? Have you got an idea how the file read write works in Python as compared to the other platforms?
Sure, Ravinda. Yeah.
Yeah. Okay, so let's try to get our hands dirty overall and try to understand how file works, right? So we normally open a file. The function returns a file objects, has a read method. You need to mention the R, W, and all those things. The normal syntax as I have given here. Let me showcase a program to you what I was doing for file read write. So I'll share my Anaconda, share my Spider, right? This is what's, no, not the JSON, not CVS. Yes. First I need to write a file, and then I'll read the file. Okay. So to write a file, this is basic 4 line of, actually it's a 2 line of code, but we are, writing 2 lines. So it's a 4 line of code. I can write it together, but I, prefer to write it again. So let me, add the line, another line, allow you to write, good SPEEdy speedify. Okay. Then I have given the guru.text. It's not yet created. So I'm going to create that guru.text for write mode. Write is W. And there's no inclusion. So file transaction is already included in the Python interpreter. And this is for Python 3.9.7 we are talking about, right? So let's try to play this thing. Come on. Yes. So as you can see, we have basically run the program successfully, right? And let's try to go and open this file. Let me open the directory first. I have a directory called, okay, let me open my file manager. Could you see my, file managers? Come on. Here I have a directory called file. This is just created. I'm at 7:55 a.m. in India on the 5th March. So let's open this thing. So we got these things. But as you can see, we just got all those things dumped into single line. We'll try to find out how to basically do it in a multiple line, or rather take it as a homework and show me how we can do it in a multiple line. Okay, try to find some reference or try to go through W3 school and you'll get all those details. Right now, I have added 3 statements which got basically collected in just one. Okay, I can do this way. So that I have 3 these things. I can add, right? I've just added a line and I'm saving it as a normal notepad. This is a plain text flat file, right? Now let's try to open this thing. Open in a read mode. I'll share these programs with you so that you can also play around with it and try to do it with multi-line and all those things, right? So I'll go to, these things, Guru1. I'm reading the file. I'm, just printing the file as a print statement. I'm just passing the complete file object to the print. Let's see how it works. Okay, let me play this thing for you. Could you see in the output window here, the console, we can see all the lines as we have inserted in the text file. Does that make sense?
Yeah. Yeah.
Sure. Now let's try the append program as well. So let me comment this thing out. Okay, what's the problem now with him? Here, okay. I have to pass a file. Okay. Give me a minute. Right?
I think we should put
Yeah.
quotes over here.
Pardon me, ma'am. Okay, let's forget about it. I don't know why it's giving me error. Triple quoted string literal to flex. That's triple quoted.
Here, I think this line is like not commented properly. Should you put n quotes also? Just 3 quotes is fine.
This one you're saying? Okay. Oh, sorry, end quote. Yes, right, ma'am. Pardon me. Normally, I don't know why. Sometimes this happens. So I'll just play these things. Okay, no, there's an error. It takes no arguments. Okay, I have given the name. So normally we don't have to specify name. Whatever file open is get closed by default. Now it's got executed. Let's try to read it again. Okay, so I'll just say hash hash hash. I'll end with hash hash hash, and here I'll uncomment these things, right? I'm really lazy person. Pardon me for that. And if I play this thing, now see, it's got appended, right? Could you see? Again, the same thing, like it's got attached to the last line. So it's got attached to the file from below. It's a leaf, first in, last out. Yes, first in, last out. Okay. So that way it works in terms of Python. Okay. Do you have any question for me? I'll share these, source code also with you. Oh, I don't open all these things. Okay. So I'll stop share. I'll start share. I'll come back here. Right. So let's go to our, dear friend, Mr. Reddy, to understand how he explains text file, read binary file. So we normally mention RB, and then how we can copy the file from one file to another. You can use for loop, or you can just use that fread pointer. Fread pointers contains a like pointer like C, and we have a complete file in a single command, and you can also copy it that way as well. Try it on your own, and we will discuss this in our next session if you have any problem. Okay, any question for me at this moment?
No, that's fine.
Okay, now second step, right? Now let's try to understand something called, okay, this we have done, right? Okay, CSV file handling. Now what is CSV? CSV is comma separated files. Now, as we know, there are many databases which are normally text-based, databases. If you look at, major database like MySQL, Postgre, Ingress, these databases, they are specifically designed for efficient text transfers. But if you look at something called Oracle have gone a couple of steps ahead, or Sybase, they have created a specific mechanism for putting the images in the database. They have certain specific compression mechanisms so that you can use this database for image throughputs as well. But if you want to do it as a normal file handling, we normally use something called CSV. CSV are normally sheets. So what we are trying to do, we are trying to get more organized in our file driver. So how do we get more organized? We use something called CSV. CSV are basically the sheets, means Excel uses sheet. There are other softwares which uses sheets, and this is started with something called Lotus Notes in good old 1980s. So Lotus Note was first software who started defining these sheets in terms of rows and column on a file or text-based files. Okay, so this CSV are comma separated file. So how I can create records in just multiple categories in a record? I separated the line. I separated the characters in the line with a specified symbol like comma. But yes, if you have a comma in your database, the file read-write can get confused. Yes, it can get confused. So we might choose some other delimiter in that scenario. But normally these are called CSV file. So comma separated files. Say mostly used for importing and exporting information. And as we normally say, these are the oldest mechanism to create a database. Basically, if you want to go to understand history, how databases are created, they are created from CSV file. So when we started basically actually storing data, the data gets stored in a tabular format on a RAM on a lowest machine level. If you know those gates, if you're a computer engineer, you might recall something called gates. Gates is in the surname of Bill Gates. So we have AND gate, NOR gate, XOR gate, and all those things, right? So those gates stored the data in a tabular format. That's why in Python data scientist, the Python modifier, Python scientist body design, understood like we can have something like CSV to be accessed efficiently from the lowest machine level. So that's why they have incorporated CSV specifically as a CSV file handling in Python. And this is also almost as efficient as text, or just a next level efficiency to the text file. And these are also get compressed more than 60% to 99%, depending on your containers, the separation, the delimiters, and blah, blah, blah things. Okay, we'll have a look at these delimiters and how it affects on compression when you define solution. But overall, just try to understand for this time being, CSV is just like enhanced text file to use text file as a database. And this is we are going to use as a database as a text file. So it'll be much more efficient than actually going to the database, right? Because going to the database, you need to create the authentication authorization cycle, then look at the particular database, then look at the particular table or tables, do performs operation like joint, whereas, and all those things, which takes some major processing cycles. But if you do it with CSV, you are ignoring all these cycles and you are just loading the file and accessing it, as simple as that. So the processing happens at much efficient level. Could you understand what I'm trying to say? Does that make sense to you?
Yes, yes. Perfect.
This is really important if you think Python as a solution platform, and you can really make sure, even if you know R or C, still Python is leading the Python data science solution development, specifically in machine learning, AI and IOTA category, because of these efficiencies. The driverless car, they work on a CSV. Yes, ma'am, please go ahead.
In big data, is that also stored in file formats, or because the data is huge there, right?
Yes, great question, ma'am. And I really respect and appreciate for these things. Yes, big data have CSVs, and those are really right, thoughtful questions. Believe me, I really appreciate something. When you ask these questions to normal, Python data science trainer, they might not be able to tell you, because I was a trainer for big data as well. I have worked with Apache Foundation as a trainer for a couple of years. So that's why I know how this CSV got implemented. And that's why I can explain you the assembly level memory mapping and how they have implemented same in the big data. That's why big data can attain the efficiency of a normal database, even if it's huge in size. Means if you compare the efficiency of a normal database to big data, the normal database, if it's, let's say, of 100 gig, and if you have big data of, let's say, 100 petabyte, they work at the same efficiency level. So almost 100 times data throughput capacity than a normal database. And how we can achieve that? Yes, due to CSV. But yes, they have improved the mechanism of CSV. They have added some securities for those indexing and all those things. So yes, you are spending a bit more cycles, but not as many cycles as a normal secure database. That's what we normally call it. Because if you look at Oracle, if you look at Sybase, these databases are wrapped like onions. They have at least 6-7 cycles got wasted before you start actually streaming the data. Just to make sure the requester is authorized for such volumes, these tables, they normally work at a table level, right? But if you look at CSV, CSV doesn't care about anything. If it's a file, bloody start the pointer, get the starting address, start pushing data. And if you are a local, well and good. CSVs at its best, they don't care about encryption, because in good old 1950s and 60s, we haven't reached to a level of try to attaining multi-level encryption alone. Single level encryption, like you can add a cipher. Cipher, right? Okay, cipher is like cipher is like you add a ASCII text. So when you say CVS, C is ASCII 68, C is 68. ASCII, I'm talking about the ASCII representation. So when you go at hex level, C is normally mentioned as /0x68. That's the pixel contents when you mention C in your actual file. I'm taking you at a hex level. Pardon me for this technicality, but as a data scientist, this is the real need to understand. And we normally have images basically painted like these of each and every pixels with the color number. We normally use hex color number, right? If you go to assembly, you can paint your screen bright depending upon your display card with so many colors. So each and every pixel has to have a hex number assigned to it whenever you try to paint your screen. And that way, we have to address those things in a hex number, 8 byte hex, 16 digit hex code normally goes to an image whenever you try to paint an image. Same way, the CSV, which is a kind of enhancement to our file where we can have actually a row record mentioned with a row number and a column number. Row number is my file line number, and column number is my CSV referencing for that line. There is a CSV reference for that line, and it's just a sequential number. The 0 is my first pixel on the leftmost side, and if I have 102, if my resolution is 1080 pixel p, so my last pixel will be 1079. Could you understand what I'm trying to say here?
Kinda.
Okay, let me add this. In a typical image, when I try to decode that image at a textual level, let's say if I have that image in my CSV file and it's not as an JPEG, I normally can store the image as a CSV file for compression and communication. So how do I do that? The Python does it for you, so you don't have to worry about that. But I'm just trying to explain you how you normally do it. The first pixel, and as I told you, this is a matrix, right? So if I have 1080 by 1024, that's a normal standard full HD screen. My first pixel is 0 by 0, second pixel is 0 by 1, and my last pixel in the first row is 0 by 1079. Because horizontally I have 1080 pixels, vertically I have 1024 pixels. No, I think I've done, sorry. Okay, vertically I have 1080. Horizontally 1080 and vertically 1024. And that's the 16.9 ratio and whatnot you call it, right? This is not a 16.9. This is, I think, the highest, HDR ratio. So this is the highest 1080 pixel you can get. I have configured my monitor with that pixels though, so that's why I can tell you. We will revise this. Don't worry. I don't want to stress you right now. Okay, pardon me for that. But it comes to my mind. That's why I'm explaining you how that image get rasterized as a CSV file. Okay, so let's try to understand the CSV file we use on a with the pandas at a text transfer level. So they are much efficient than using the binary data or even database for that matters. Because even if you textual field in data, they have a couple of cycles got wasted while clearing this authentication, authorization, the data stream lane, the checksums, and whatnot, all type of flora and fauna we normally attach to the so-called secure communication. Could you understand what I'm trying to what I've just said?
Yeah.
What about you, Balaji? Okay, no problem. So let's go. So here, let's try to understand how this CSV file thing works. So these are kind of replacement to our database, right? And now, as you know, Facebook is using image recognitions with Python, and that's how they do it basically. So what is image recognition? You try to understand apple versus oranges by the machine itself. So your computer can identify apple versus oranges. That's at the crude level. The face recognition is that highest point where if you take a picture of Ravindra Pandey from, let's say, all 4 dimensions, then the recognition software can recognize Ravindra's picture, even if you have, beard, mustache, and some additional facial accessories. Still, facial recognition can recognize you amongst a couple of people. It's not that matured yet, but still we are reaching there fast and by leaps and bounds. Okay, so in face recognition we use these techniques, and we use something called pandas. Pandas is one of the libraries we're going to use to make sure we understand, because CSV file is a kind of added mechanism to the file handling, right? File handling is done by Python internally as a Python interpreter, but when it comes to CSV, there's a bit of addressal at its lower level. So we use Python library to understand CSV and do the communication as a textual communication with the maximum efficiency. Okay, let me take you to the spider and let me show you an example of loading a CSV file. I have already coded this thing, CSV reading. So now here we are importing CSV from Pandas. So there's a what you can say CSV module, specifically a downgraded value library from Pandas. Pandas is because Pandas have quite a few other facilities also, but then they have extrapolated CVS as a special library for scientists who don't want the flora and fauna Pandas as a complete library, but you can just basically have here Pandas and it will work for you as well. Okay, now what I'm trying to do here, I'm trying to pull this file called appl CSV. Let me show you my directory as well, so you can where's the directory? Okay, here could you see appl? Yes, I have this file called appl, a simple 1 KB file. If I open it, it gets opened in an Excel. So as spreadsheet, this is a simple Excel sheet, right? Could you see this scene?
Yes, yes, I can see.
As appl.csv, and it's open as a spreadsheet. So this is my first line of the file, second line of the file, and so on and so forth. So I have total 15 line of files, 15 line of records in my file, and these are the.
Can you
Sorry.
share that file? I can only see your file manager.
Oh, sorry, ma'am. Sorry. Extremely sorry. I forgot to share the Excel. Yes. Okay. Could you see this, ma'am? It normally gets opened in Excel. I'll share the CSV file as well, so you can practice it on, or you can try to create one CSV file. Try to write it in a text mode and then name it as a CSV and open it in Excel. That also you can do, because as far as Python, this is a text file with some special additions. But for reading, you'll need that CVS library. So you need to import CSV. That's a CSV module specifically toned down for CSV communication. Otherwise, you can just use Pandas. Okay. And the way you use libraries, just say import and library name, as simple as that. So this is the file I have with me. And if you want to share you what we've just discussed in terms of records and categories. So this is my, now this is 15 by 5 matrix, 15 by 1, 2, 3, 4, 5, 6 matrix. As it's get printed or loaded in a memory, this is 00, 01, 02, 03, 05. This is 15, 6. Could you understand these things?
Yes.
Yeah. So database does this for you, but as we are using text as a CSV file, we need to remember the matrix address for a particular textual element, for a particular typical cell. If you want to mention it as a cell, as this is my record, this is my category, so this is my cell. So record is a line here rather than row of a data table, and the column is basically the category or the number of field from the start. This being 0, first, second, and so on and so forth. Okay, so let's try to read these things. I don't want to save it because it will get saved as an Excel as. Okay, so I'll just say skip. Okay, and I'll go to my spider and try to run this program. So what I'm trying to do, I have fields and rows. Rows are my line number, fields are my categories. So I'll open file name, read as in read, and in file name I have passed a parameter apple.csv as in CSV file. So I need to mention as in CSV file, right? And as I'm using CVS, So rather than using basic file opening, I normally use with open from CSV and open the CSV file. And then I have a matrix called CSV reader where I dump this file. And then I started extracting it, and basically I'll use a printf with CSV and line numbers, because as a textual line, as we've seen, we normally read it with a line. So line is a row here. Okay, I'll share this program with you so that you can understand. And then I can actually print first 5. First, if I mention 5 here, it's a for loop, right? Simple for loop for a line, as that done by the Naveen fellow. So here I'm using first 5. So it'll basically print first 5. Okay. Oh, what was this? Okay. I've clicked by mistake. Pardon me for that. So let me try to run this. Go ahead, ma'am. Any question for me?
Yeah, on line 25, what does the next do? Fields equal to next.
Next line, na? Because
line 25, yeah.
By one, right?
Okay.
See, we need to understand that matrix thing. Matrix is a row by column. So row is 0, comma, column number.
Okay.
And I need to increment it by line because it's a text at sys based, right?
Okay.
So, and that's how I'm doing it. So let's try to run these things. See, it's got me my first 5 records, right? First 5 rows are this much. I've included those, text and everything, so you can basically have these things. Okay.
Okay.
And try to play around with this. I'm going to share these, Python files also with you, so you can understand. Okay. And in next few sessions, we'll also work with GitHub. So as I requested you to register for GitHub, we can integrate GitHub with Python, so you can get the files from GitHub directly. You can get the file from my libraries as well, and we'll work on that. Okay, so let's try to this is how the CSV file works for us, and this is really an efficient mechanism in Python, specifically when you talk to data scientists, right? Okay, and I'll share this thing with you. Now, another really great mechanism which we need to understand today is basically functions, because we have to use these functions, right? Whatever you done it earlier, R or C or Java, you normally use functions or methods, right? Here we use they are normally referred as a functions, and the way we do it, basically just define it and the argument. So I'm defining a function called greet with the argument called name. Okay, here I have not typecasted anything. Even the argument is not typecasted. But whenever I say, whenever I pass parameter, it get typecast to the specific input given by me or argument passed by anybody else within the programming gamut. So that's how it works. And functions, as we all know, it's an inbuilt part of the interpreter or compiler wherever we go. So this is kind of simple 3-line program. The first line is defining a defining a function. Second line is printing the function or calling the function. Print hello name. Yeah, I'm just printing it, and call the function is basically this way. Now, to understand how function works in Python in sequential way. So whenever you define a function, the next line normally get its by default called for validations, and then we have a function name. The declaration get executed at a later point. So wherever you declare it, it's get basically kind of partially cooked or partially inbuilt. I know this is not never asked by anyone in the interview, but I'm just sharing with you. If you can see the image on the top right corner, this is how the function get executed in normally Python. Okay, I'll share you some textual link also. I believe I took this image from W3C website, where they have mentioned step by step how the function and the declaration get looped in. Def is basically define the function, right? And then I call the function with a semicolon at the end, right? Let's try to understand from these, good video by a scientist in a Geeks for website. Okay, so let me play that video for you, and we'll understand how this function works works in Python specifically. So I think it's exiting that download. Yes. What's up, guys? Let me share this thing for you. Yes. So, till this point, we've learned overall how to use user-defined functions, how we are using the Python-defined function, the internal functions. That's what we call. So user-defined functions are basically the functions which we define inline in the program, right? So here, what we do, we just mention the def function name and argument if you need to pass any. The homework is basically try to create a calculator type of functions, add, subtract, multiply, delete. Use try and catch for division, because there could be divided by 0 kind of scenario. And then let's present that program in our next session. So we are fine with all the basic nitty-gritty of programming as of now. So the programming learning will definitely continue, but overall the guidance part of programming, like how we do programming in Python, is almost complete. And the next programming will start with actually pandas and all. Before that, we want to understand some statistical functions. So these statistical functions will start in our next session, right? Oh, I have this object. Okay, let's work on object oriented typical definition in our next session. This will be hardly take 5 or 10 minutes, and then we actually move on to the statistical functions, basically the mean, medium, mode, and then go deep into how we consume data as a data scientist. Okay, and how we build solution based on these mathematical functions. So yes, next few sessions are going to be a bit more of theoretical rather than practical. And then let's say in a week's time, we'll move to actual data scientist hands-on practices. So please gear up. Please do try whatever we learned till date, because we really don't want to waste time in catching up, right? Because otherwise I'll keep running ahead and you'll keep catching up with me. So please don't do that. Do practice. If you want, do let me know. We can skip a class or two, no worries there. But the practice is really important, the hands-on practice of it. Till you do it on your own, you don't really understand how difficult or how easy it is. Like we say, right? I couldn't have that, what you can say, the file close type of stuff working, because the close is normally without any parameter. It gets closed whatever the file you open the latest, and that's how it works. Okay, but still, once you try, you'll get to know these things. Okay, so I'll wrap up my class right here, unless you have any question for me at this moment. Anyone have any question for me?
We are
No.
good. Ravindra. Yeah.
Okay, I'll share this recording. We'll publish on YouTube as well. Okay, thanks a lot for your time. Have a great weekend. Good night.
Thank you.
Bye bye. Take care.